The current approach to protect the Belgian coast is starting to fail. Climate scientists, they expect or report that in the past 85 years the sea level increased with 15 centimeters. Furthermore, they expect that the sea level will increase with a minimum of 80 centimeters in the end of this century. So continuously nourishing our coastline, restoring our coastline with bulldozers, that's not a solution. That's a very expensive way. So in the future, it's better to aim for a natural and dynamic coastline. So natural coastlines is much cheaper than artificial coastlines because it's cheaper in terms of management, but it also can grow with the sea level rise. But therefore, it's needed to have a natural interaction of sand between sandbanks, beaches, and dunes. So in the winter periods, when there's more chance on storms, there is an erosion of sand off the beach towards the sea. And in the calmer summer periods, this sand is given back to the beach where wind moves it up the beach further and to the dunes where bigger and new dunes are growing, which is perfect for coastal protection. And here is where my research begins. So, hi, my name is Strypsteen and I'm a PhD student at KU Leuven campus Bruges, and I study the wind-blown sand transport at the Belgian coast. And in today's talk I'm going to share with you the importance of wind-blown sand transport in coastal environments and how we actually measure it. So wind-blown sand transport is a topic which has been investigated since the beginning of last century, but it's only since the recent years that it's being investigated in coastal areas. So opposed to storm wave processes leading to erosion of the beach, we actually don't know a lot about wind-blown processes leading to accretion of the beach and dunes. And in Belgium, sand transport by winds was never being quantified or intensively studied. And research about the natural growth of the beach and dunes is of course very relevant, and people often don't know how these processes are working. So for the past 2 years, the morphological behavior of the coastline is measured by innovative monitoring techniques in 2 study areas. So we have one study area in the natural environment of Koksheden, so where you have a beach and a dune, and we also do measurements in an artificial environment where you have a beach and dike in Mariakerkebad near Ostend. So in every campaign, we use a lot of instruments where we measure some parameters relevant to wind-blown sand transport. So for example, we use vertical sand traps where we measure the total amount of sand transport, but we also use devices that measure how intensive transport occurred. We also measure the wind speed, wind direction and temperature, and we also measure the topography, so we can see changes during those transport events. Also, we measure the moisture content of the top layer of the beach surface, because that's a very important influential parameter in the wind-blown sand transport processes. And the results already show that sand transport is depending on local conditions, such as beach dimensions, beach profile, but also the meteorological conditions and surface characteristics. So imagine, for example, you have a very wide beach, and the wind has more chance to transport sand by wind and vice versa. Also the angle of wind approach is also very important. So imagine you have longshore winds. Those tends to have more transport capacity than, for example, onshore winds. Also you need to have a minimum amount of wind speed to induce transport. And also, for example, if it rains or after a high tide, the beach is of course very wet, which makes it very difficult to transport sand. So you see, you have a lot of influential parameters influencing the wind-blown sand transport processes in coastal environments. And this brings me to the end of my talk. So my name was Strypsteen, and I talked about the importance of wind-blown sand transport processes in coastal environments and how we measure them. Thank you.